Hey guys, this week is just gonna be a little bit of review, kind of doing integral that goes a little outside the box, something you're not really used to. That might be a little fun just to like stretch your knowledge. Okay, so right here, right? Cosine of the square root of x dx. Now, as you see this, you think of there's something inside a cosine or a sine, and then your first thought should be u sub. So let's just throw it in there for fun, right? Like we know there's nothing on the outside here. We know this is a half power, so it's not going to get to like 1 or anything. So when we take the derivative in our u sub, so we're going to have to change this around a little bit. But you know our only option right now really is u sub. So let's make this x to 1/2, and then we're going to do du. And that's just going to be the derivative, right? So 1/2. Put a square root of x on the bottom. And we'll make sure we know in our brains that this also just equals square root of x. And then we'll do dx, right? So I know u equals the square root of x. And we know du equals 1/2 square root of x on the bottom, dx. Now we kind of look at this, and there's really nothing how we can create the du in this problem. So we kind of have to manipulate this thing a bit to get to what we want. So we're going to do 2 square root of x du equals dx. Because don't we always multiply over what we kind of like just want to throw in there, like some constants, right? So like our 2, we usually know to do that. Our square root of x is a little bit of a new idea. So then with this, we kind of think, well, how can we change this all to u's? And then we realize that this square root of x is the same as this square root of x, right? Square root of x's don't change, right? So we have 2u du equals dx. Okay, well that's good, right? Can we kind of like extrapolate from that and bring that into here? So let's try that. So let's do cosine of u, right? And then our dx equals 2u du. Okay, that's sweet, right? Now, fun begins, and we can do integration by parts, right? So we can do u, du, dv. Now, if you were to go and do this one yourself, you might want to for your u sub use a different value than u, just to make it easier on yourself. Maybe like t or something. Since we're using u's right here, and that might get you mixed up. So which way? A good way to do this would probably just be, we have to make this simpler on ourselves, right? Because it's uv minus v du. So here, let's write it. uv minus v du. Just so that we remember, right? So let's do it this way. Let's do 2u, let's make this 2 du. Okay? So at least we simplify something. We were with the cosine there, the 2 on the other side, we just make it bigger. So cosine, so here, let's put these separate. Making it all messy here. That's okay. Cosine u du, or here, let's just, well, yeah. I mixed it up right there, but it's just including everything. So, and the derivative of that is negative sign, right? Or the integral, I mean. Well, then the integral will be positive sign, right? Because the derivative of sine is cosine, so thinking backwards, you just get sine right here. So now, let's put it all together. So uv, so 2u sine of of u minus v du. So let's do v. So integral of sine of u to du. Okay, that's not too bad, right? Because now all we have to do is, let's just put our u's in right now. So square root of x, so 2 square root of x sine of square root of x minus. Now for this one, is the integral is going to be 2 cosine negative, right? Right? Okay, so then we're going to have plus here, right? Because negative, negative. 2 cosine u, but it's going to be square root of x, right? And then don't forget your plus c. Then you got your answer. Looks all beautiful. And yeah, adios amigos.